Hello everyone, and welcome to this lesson. C in 42 minutes, almost. Before anything, small clarification. This lesson is not meant to teach you how to program in C. It's not an exhaustive description of the language. Its sole purpose is to bring forward elements you'll need to complete this bootcamp. It's a subset of C, which will allow you to accomplish everything that's asked of you during this bootcamp. Before even starting to write code, first thing you need to understand is what's a computer, what's in it, and how does it work. So, a machine is made of three elements. The first is the CPU. It's the one that processes all calculations, all computations. All of these actions are made in the CPU. The second element is the RAM. The RAM is a tool, an object that will hold everything that's been memorized by the computer. So this second element is very important. And last, the third element is made of computer peripherals. That's what will allow you to connect your computer to the rest of the world. So we have these three elements. These three elements are interlinked by a system called bus, which will allow information to be transferred. There's also a clock system which will allow all of this to operate together. So, of course, a computer is much more complex than what we've described. But that's, I would say, the image, or at least the representation, we'll need during the rest of this bootcamp. And also for a while during first year at the school. So let's keep this basic description for now. I'll say it again. A processor, CPU, so a treatment unit of a memorization system, which we call RAM, and a system or interface which the rest of the devices connect. In other words, devices. And programming, what does it mean? Programming in the end, compared to what we've seen before, meaning the paradigm of the computer's description, consists in giving instructions to the processor, meaning a list of elementary actions which will handle data. So we'll be able to do extremely simple actions, like for example, comparing two data. A simple operation such as an addition, a subtraction, or a division. We'll be able to relay an information in a new address. So we'll be able to copy the data of an address into another. We'll be able to do basic arithmetics, basic comparisons, and we'll be able to send these data to a device, for example, display them on screen, or simply forward them. What you need to understand is that we're trying to do two things. They're extremely elementary, but that will be done extremely fast and in a very large quantity. These elementary instructions will allow us to simulate extremely complicated behaviors, maybe even simulate intelligence. However, today our programming system won't be able to just do extremely elementary things. So what about C in all of that? In the end, the computer will process a language, which is called computer language, which is a very elementary language, directly made of codes that are particularly unpleasant for human beings. The C language is a layer above of this. It's a relatively simple language that's close to the computer's language. Here, we'll have a sequential language which will overall have a translation in rather elementary operations. So nothing too complicated. However, it'll be readable and pretty simple to use by a human being, which will make this process efficient. So, we have a system that will be complicated, meaning we'll transform the C language into something we write in computer language. Then this computer language will be executed by the processor, and it will be readable by human beings. And it will compile, so it's particularly efficient, all by letting a set of functionalities that are relatively evolved, allowing us to function correctly. Another important layer to integrate is the operating system. The operating system is the software that will make the computer work. It will be launched at the startup, and it will allow us to have an interface between the user and the machine. The OS. We'll see more complex definitions and descriptions later on, because it's a very complex object that's been elaborated with a lot of work for a very long time. The OS is the result of a strong evolution. This object will manage the entire functioning of the computer. and your program will interface itself with the OS. To be clear, when, for example, you want to display a character, your program written in C will tell the OS via what we call system calls, I want this character to be displayed. And it's the OS that'll do the job, which means in your program you don't need to code the entire system that'll lead to displaying a character. So C will allow you to write simple instructions, which will allow you to interface with the OS, which will also interface itself with the hardware to display or to carry out the actions you need. As we've seen previously, the computer holds memory. So it holds data and will be able to run processes on these data, so follow instructions. A C program is the representation not only of the data we'll process, which means we'll have information about these data, but also instructions. In the RAM, we'll depict the data by groups of 8, which we call bytes. It's a group of 8 bits, so 8 ones and zeros. We'll call that a byte. It allows us to represent numbers from 0 to 255, depending on their representations. And each of these bytes will be given an address, which will allow us to recognize it and find it. C will allow us to work on these bytes, and so work on the address system. C uses types to represent data, and so we'll have several types. The first type is what we call char, C-H-A-R, which is an 8-bit, so a byte. So it can represent numbers from -128 to +127. And the basic arithmetic is affected to it, which will allow it to handle all usual processes, divisions, subtractions, etc. The second type is the unsigned char, which is also 8 bits, but that'll have another representation, which will go from 0 to 255. Then you have what we call a short, which is 2 bytes, out of 16 bits, which will allow us to represent from -32,000 up to +32,000. You also have the unsigned short, skipping a few details. You have the int, which is on 4 bytes, and it generally is the data structure. We use the most because it allows us to do most processes. You also have the unsigned int, the long and the long, which allows us to represent data up to 64 bits. You have the unsigned long, and you have the last type, which is called the star or the asterisk or pointer, which allows to hold not just a data, but the address of a data. We can consider that a data's address is also a data itself, but there's a special arithmetic that we'll see later on. Now that we know how to represent data, let's start talking about a program structure. A program structure is a set of functions. What we call a function is an entity said to be closed because data is in this entity, or supposed to be closed, to the rest of the world which gets this information, which we call parameters, and which will return a result, and between the two we have a process, and we'll see how it works. A function is always made of two things, instructions and local variables. Here you see the first syntax element, the declaration of a function. A function can be declared rather simply. We define its type, meaning the type of what that function returns, because a function takes values as entities, which we call parameters, and returns a result. So the type you see first on this prototype is the return values type. Then we have the function's name, and then the list of parameters, which are every time the type of the first parameter, the name of the first parameter, the type of the second parameter, the name of the second parameter, etc., etc. There can be as many parameters as we want. There can also be none at all. If there's no parameter, we simply write opening brackets, closing brackets. That is what defines what the function is and what it takes for parameters and right after. there's what we call a block. A block contains the function itself. A function is always split into two parts. The second part, the block, is between curly brackets. So there's an opening curly bracket, the declaration of local variables, followed by instructions. There could be only one instruction. There could be no local variable. There could be no instruction. And we always end with a closing curly bracket. Here's a quick example. Of a small function, here we'll declare a function called sum brackets, which returns an int, and which takes two parameters. A parameter value 1, which is of type int, and a second parameter value 2, which is also an int. This function starts at block, so opening curly bracket. Int total declares a new int called total and is also a local variable. The functions are closed, which means outside of the function the variables don't exist. Therefore, it's local. Then we've got the instructions. In this example, there aren't any, but that's where they'd be. And finally, the closing curly bracket, end of the block, end of the function. In C, we can declare what we call combined types. There are data structures which are made of elementary types, which we saw earlier on. There are a few, but during this boot camp, we'll only use two. The first is the array. An array is a succession of objects of the same type in the memory. It's easily declared. Type, comma, name. Opening square bracket, number of elements in the array, closing square bracket. You've got an example on the right. Int tab square brackets 42, which is the declaration of an array which can contain 42 integers. The array's index goes from 0 to 41. We always start at 0, so with this array, you've reserved 42 ints in the memory. To access them, we write the name, opening square bracket, the number of the int we want, closing square bracket. For example, if we write int tab square brackets 12, we'll get the 13th int. The second combined type is a bit more complex, and we will use it later on. It's called data structure. The structure will allow us to define the representation of an object in memory, which will be made of basic elements that could very well be structures too. You have to know we can interlink structures, arrays, etc. Let's check out how to declare a structure. We write struct, the name of our structure, opening curly bracket. We declare the structure's components, type, name, etc. Closing curly brackets and semicolon. Here we've just declared a structure. There's an example on the right where we declare a structure s underscore 42. It's made of an int called a and an array of 21 characters called b. We define it in a simple manner indicated below. We declare the structure, and when we write struct, name of the structure, name of the variable, semicolon, it reserves the necessary memory area. And when we use this name, the program will know we're talking about a structure. The compiler in C is usually pretty permissive. In terms of syntax, you can write things in many different ways, but to make things more readable and have some sort of consistency, we've defined a standard, a norm. The standard will be presented later on. You'll have a specific lesson on this topic. It's important for you to understand that using the standard has a lot of advantages. The first advantage is that it allows you to easily read each other's code. The second is that it helps learn how to program in a structured way. You'll see that even if you've already programmed before, the school standard will still be an adjustment. Its biggest advantage is that it gives us a look and feel and helps for the reading. When we read someone else's code, being used to a standard will allow us to read faster. We please ask you to respect it. We have a program that checks whether the standard's been respected. We've seen that a program was a set of functions and that there can be many functions. So where to start from? It has been defined that in C syntax originally, the function that will be executed first, the one that will trigger the program's execution, is the function's main. So if you create a program, somewhere in your code there'll be a function main. It's a function that takes a certain number of parameters. You'll see later how they work and how to use them. Main returns an int, but you'll see how this also works. This way you'll systematically have this declaration. Int main, the parameters between parentheses, if there are any, and the functions block. Now that we've seen the general structure of a program and we've seen how to represent data, all that remains is how instructions work. Of course, now that we know how to declare data, we need to learn how to act on these data. It's quite simple. There are three types of instructions. There's what we call blocks, which, as we've seen, are always made of an opening curly bracket, a collection of local variable declarations local to the block, instructions which will be executed by that block, and a closing curly bracket. There's also what we call expressions, which will be followed by a semicolon, and make a numerical calculation or evaluation happen. We'll go into this later on. And then we have what we call control structures, which allows to control the proceedings of a series of instructions inside a block. Let's start with expressions. So, expressions, as we've said, are a set of evaluations which will give results. The simplest of evaluations is a numerical value. For example, if you wrote a number here, 0 and 42. You can write it in hex, OXA, in octal, 010, and it will evaluate itself to its own value, meaning that the compiler will make sure it's worth its result. The second type of expression, variables. Once we've got a variable, when we use it, it'll go evaluate directly to the variable's value. If, for instance, you have a value in an int a, like in the example, when you write a, it'll be worth the value that's in a. Same thing for an array. If you wrote b square brackets 18, it'll look for the 19th element held in b. In the case of a structure, if you have a structure element called sft underscore var dot a, it'll look for the element a in the structure sft underscore var. So a variable is evaluated directly by the value it contains. The third type of expression is what we call function calls. We write the name of the function. The parameters will pass to this function. The compiler will call the function, and it will be evaluated to the function's return value. We've seen that a function takes parameters for entry, does the process we ask it to do, and returns a value. So this value will be set instead of the function. In the following calculation, we'll have a function. We can combine all these elements thanks to computations. This way, the compiler will process the arithmetics, and as you can see below, we can write very complicated things. If you write 1 plus 3, it'll take the 1 and add 3 to it. It handles parentheses and priorities, operations. There's a b square brackets 0, which will get the first element of the array b. When it'll write a times 42, it'll go get the value of a. It'll divide by the sum of two elements, returned by the function sum. The compiler will manage to evaluate, calculate the result of these arithmetic expressions, and will do it in the right order. The last type of expressions, assignations. And an assignation is, for instance, when we write a equals 42. the compiler will set the value 42 to the variable a and will return as a result 42. We'll systematically have an assignation and an evaluation. For example, if you write b square brackets 2 plus a, we'll get the value contained in a and add 2 to it. This value serves as an index to go read in array b. We'll calculate the result of the function that's on the right. We'll assign it in the array and we'll return as a result the function's result. It's an assignation and it'll modify the data in the variable. There are other expressions. We have what we call comparisons. A comparison in C is an operator which will be evaluated just like any other expression to a value. We call true the return value 1 and false the return value 0. So when you write, for instance, a does not equal b, a equal b, it'll check if the content of variable a is equal to the content of variable b. If both contents are equal, it'll return 1, else it'll return 0. All comparators work the same way. Another example, if you write a less than b, it'll check the values of a and b. If a is indeed inferior to b or less than b, it'll return 1, else it will return 0. As operators, you have equal equal, which compares equally, exclamation mark equal, which means different than, less than, greater than or equal to, less than or equal to, or two pipes, logical or, and ampersand, ampersand, logical and, an exclamation mark, which is a negation. If we write exclamation mark a, if a is worth 0, then it will return 1, else it returns 0. So, these are comparison operators. We also have what we call binary operators. These operators will process the variable's binary data directly. We'll go into more details on this later on, because it's not very useful for now. But it allows us to process each of the bits contained in variables. Then we have shortcuts, which allow to facilitate the reading. For instance, we can write a plus equals 10. That's just like writing a equals a plus 10. We could write a plus plus, which is the same as writing a equals a plus 1. We can write / equals. That's the same as doing a division. Those are just means to simplify writing. There are some special expression elements. For example, capital A returns the ASCII code for the character between the apostrophes. Actually, the ASCII code for A is 65. ASCII codes are extremely important as they allow us to display characters. There's an ASCII table, but we'll get back to this later on. We have the operator size of. We write size of. The type of variable of directly a variable, and this will return the size this variable takes up in the memory. The last one, if we add an ampersand before, it'll return the address of this variable in the memory. There's what we call a ternary operator, even if we rarely use it. Syntax is as follows, and expression, exclamation mark. A second expression, colon, and it will evaluate the first expression. If the expression isn't null, it will evaluate the second and return its value, return it as a value. Or else it will evaluate the third expression and return it as a value. So it's a conditional expression. The last point is what we call character strings. A string is a series of characters between inverted commas. This will allocate memory for the characters between inverted commas. It'll add \0 in the end and it'll return the address of the first character. We've seen when we listed types that there's a particular type. Pointers. A pointer is a variable like the others, except that instead of storing data, it'll store the address of another variable. Well, at least the data's address. It's a pointer to something. So, as the name suggests, it contains the address of something. How to declare a pointer? First we have to declare the type of what we point to, meaning the variable's type, whose address we want to store. So we write the type star the name. An example, if I write int star p, p stores the address of a variable of type int. How do we use them? Quite simply. Once we've declared a pointer of type int, as I did just there, we write p equals &a. We'll see the address of a in p. Then we'll use star p. We do p equals 1, it'll set 1 inside the address pointed by p. It's the same as writing a equals 1, as p contains the address of a. So if p contains the address of a, star p is the same thing as a. It's the same memory area, the same address, and the same type. Basically, we can say that star name, so star the name of a variable of type pointer, is the object of type type, whose address is stored in name. That's very important. You must systematically refer to this definition. When I have a pointer called name of type type, name is the object of type type stored in name. So we have an arithmetic system. Let's take an array, tab square brackets 42. So p, an object of type pointer, which stores the address of tab's first element. If we write star open brackets p plus x close brackets, we access the value located at the position of x of our array. Same as if we wrote tab square brackets x. So, up till now, we've seen variable declarations, instructions, and now we're left with control structures. In C, there are several control structures. We'll see 3. Actually, we'll see 4, because 2 of them are very much alike. The first is the control structure if. It's quite simple. We write if brackets expression, close brackets, and then an instruction. This instruction can be a block, which means it can contain several instructions and declarations. How does it work? It's simple. It evaluates the expression. So we're going to calculate the result of the expression. If the expression returns 0, it doesn't do anything. If it returns something else than 0, it'll execute the instruction. It's a simple test and quite practical to use. There's a more elaborated version, which is if expression curly brackets instruction, else curly brackets other instruction. As you can imagine, it evaluates the expression. If the expression is worth 0, it executes the second expression. If the expression is worth 1, it executes the first expression. It's a rather simple thing. Second control structure, the structure while. The structure while is quite simple. While brackets expression and an instruction. The process is a little different. The while evaluates the expression. If the expression is worth 0, it stops. If it's worth something other than 0, we'll execute the instruction. So far, it's just like with an if, except that instead of stopping here, we loop, which means we reevaluate the expression. If the expression is worth 0, we stop, else we execute the instruction again, and we go back to the start. As its name suggests, we'll execute the instruction while the expression isn't worth 0. That's how all loops work. That's how you'll use them during this bootcamp. There are other control instructions, but you'll just use these ones for now. The last control structure, the structure return, which allows to return a value at the exit of a function. As we've seen, the function takes parameters as entries and returns a value upon exit. Return allows us to return this value. Return brackets underscore bracket calculates the expression and stops the function. This means that if there are other instructions after this return, they won't be executed. The function's return value will be the result of the expression. There's another type of return without a return value, meant for a particular type of a function. We haven't seen yet, but you'll see that later. Those are functions that can't return values and which have a different syntax. That's it for this lesson about C.